All right, so first of all, the more observant among you will notice that my name is actually not Greg. Greg unfortunately had a family commitment and couldn't make it to the conference, so he's handed me all his slides and briefed me, and I'll be doing that in his place. Unfortunately, this news didn't come to us until after I'd booked my flight. So, in essence, as soon as the presentation was over, I got to close up and race over to the airport. But we should have plenty of time just to get through the slides and maybe answer a few questions. So, is anyone here? I mean, who here has heard of Bucardo before? A few people. Anyone actually using it in production now? No. Interesting. Well, for a little summary, Bucardo is actually a standalone replication system. It's outside the database, of course. It's designed to connect to Postgres. It can replicate between Postgres and other Postgres instances, and it can also push data from Postgres to other different database systems. It is trigger-based and asynchronous. Trigger-based, it works at the logical level, and so it sees the data as it is in the database. You don't have to worry about any statements being replayed that are different on one side than another. Currently, it's going through a little bit of a rewrite. The current production release is master and multiple slave, or master-master. On the horizon, we actually have a beta out now, is Bucardo 5, and it actually is multi-master and multi-slave. So, for instance, you could have 3 masters, 2 slave databases pretty much anywhere. So, the state of Bucardo, where we are now, started at backcountry.com, kind of an e-commerce site with hiking equipment and all kinds of cool stuff. Back in 2002. Back in the day on Postgres 7.2, that's my first version too. So, yeah, it's been out there for a little while. It was released to the public in 2007 as version 3.0.6. I don't know why they started at 3.0.6 and suddenly made it public, but a little bit down the road, version 4 came out in about 2009. It's kind of stalled as far as its development goes. Any active development is actually going into Bucardo 5 now. A lot of it's been planning and restructuring things, but for the last 3 years, we've been working on redeveloping it. Bucardo 5 is actually mostly a rewrite. It's got the new version will have a lot of new features over the Bucardo 4 release. In fact, a larger set of new features than the version 3 to version 4 jump. Some of its strengths compared to other replication technologies, it's fairly lightweight as far as requirements go. In the minimum version is Postgres 8.3. If you're using older than that, you probably should start looking at upgrading anyway. Runs on Perl, requires DBDPG, of course. It does require DBIX safe, which you can find on either CPAN or the Bucardo.org site, and does require PL-PerlU in your database. Apart from PL-PerlU, if you don't have that installed, it doesn't really need any changes to the Postgres configuration. So in theory, you should be able to just drop it in place, point it at your databases, and go. It only has a single process. It can be run from anywhere, which is not exactly true, but I'll get into the one case a little bit later. It's very fast, and it's very tolerant of bad networks. So if you've got a long-distance replication link that's flaky, it drops connections, goes down for even long periods of time, it doesn't care too much. It'll reconnect when it comes back up online and pick up where it left off. It's got pretty good monitoring built in. If you're at my monitoring talk yesterday, I think I mentioned it. I think it has some Nagios plugins built in, so you can just point Nagios at it and tell it what command to run, and it'll tell you what the current status is. And it's super easy to install and set up. We'll go through the procedure a little bit later. some more strengths. It's the targets, the slave systems aren't locked, so it doesn't prevent you from writing to those if you wanted to replicate, a small amount of data. It's very configurable. You can run custom code, and I'll get into that a little bit later, what that implies. The new version will have multiple target databases, MongoDB, Oracle, et cetera, et cetera, et cetera. And the big key there is it's multi-master. Now, it does have limitations, of course, as anything that has trade-offs does. No DDL. Postgres, of course, at this point in time, doesn't have any type of DDL triggers. Bucardo's trigger-based, so if you change something, we don't really know. So that's something to work around. There's no automatic failover. If your master goes down, you have to basically turn Bucardo off and point your systems at the new master. No delta replication without primary keys. There is a workaround. It's essentially as soon as something changes in the table, it'll do a full copy of that entire table over to the replication or the slave system. Which, if you've got a small, maybe like a table with listing flags or something, it might be okay. But that sometimes is a showstopper. We had actually in the last month we had a client that wanted to move to 9.0. And we originally started looking at Bucardo with them and then look at their schema, and they've got about 1,000 tables. 800 of them lacked primary keys. I don't know. It wasn't my system, so we just kind of did a dump and restore, and they had to wait a little bit longer than they would have, but yeah. So always use primary keys. One of the limitations, I mentioned this already, but targets are not locked. Maybe that's a bad thing. If you want to prevent someone from writing to it, if you've had a failover happen, you bring up another application server sometime later, it still points to what I guess would now become your new slave and starts writing to it, and you've got two separate sets of data that won't meet up anymore. The process, when I mentioned the process doesn't actually run everywhere, it doesn't run on Windows. It's probably just a matter of a little simple matter of programming, but at the moment it just doesn't run there. Your databases can, which if you just have a little Linux system pointing at all your Windows databases, you'll probably be fine. One of the older limitations is bloat. It stores all its replication status, queues, staging area in its own tables. So if you have a lot of churn, those can fill up pretty quickly with dead rows. That's been partially solved in the new design for Bucardo 5. As far as what's new in Bucardo 5, the code's been overhauled almost entirely. Some of the synchronization's much faster. The syncs, there's no swaps or push deltas anymore. Everything has gone asynchronous. Again, the big feature bullet point is multi-master. You can have as many masters as you want, and it lets you push to other database systems. There's no queue table if you're familiar with the old design, so that equates to less bloat, faster queries. The old version had you basically had either debug logging where it told you everything it does, or some basically log errors, and this gives it a little bit more finer grain control over it. Control line's been overhauled, monitoring's been overhauled, and uses some of the new Postgres stuff. Actually, it's hidden behind the. By the way, Bucardo is a type of goat. It's actually extinct, but I don't know where the name came from, but that's why there's a goat there. And hidden underneath the goat is the word unlogged. Hidden under the goat's butt is unlogged, which is a very cool new feature in 9.1. there's a table or a set of tables where it stages. If you've got multiple slaves, it'll stage the new rows in a kind of like a poor man's prepared transaction or distributed transaction type of thing. And it uses the unlock tables to do that because if those tables go away, if their database crashes and comes back online, we can always rebuild that. So it takes advantage of the new performance features there. Some of the use cases, like any replication, you can distribute your read load, have your master that you write to, and as many read slaves as you want. Redundant master servers, of course. Data warehousing, data reporting, also kind of the same thing. Because it's trigger-based and doesn't rely on the write-ahead log or anything like that, you can use it to upgrade versions. Anything, why does it say 8.1? I thought the requirement was 8.3. Yeah, that's even better then. Upgrade anything, 8.1, upgrade to newer versions with very little downtime. It keeps your new version up in sync with the old one, and at some point in time you say, okay, I'm going to go down, point the application at the new database and come back up, and you're ready to go. If you're eager to join the NoSQL craze, like MongoDB and stuff, the new version 5 has MongoDB targets. If you've got an app that's old and no one wants to touch it and it needs Oracle, you want to go to Postgres, well, keep your Oracle instance up and running. Just replicate data to it. OK, so a little bit of a tutorial. To install it, your packaging system, I think RHEL has picked it up. Debian definitely has as of the latest version. And there's a couple people that have packaged it separately. But beware of old versions. Like I said, we're putting a lot of development into the new version, so it's moving pretty quickly. So those packages are getting out of date fairly fast. So to get the latest and greatest, just do a git clone of the bucardo.org. There's also a tarball there. And like I said, the installation is very simple. Do a Perl and a make file, make sudo make install. Done. Now, installing the daemon process, do a Bucardo install. That should put it in place. Bucardo show all will give you a list of all your system variables, things that you can set. So that's pretty much all it is to get it up in place. Next step, tell it what databases to tell what databases, what sources of data you have, or maybe even targets. Just a matter of saying Bucardo add DB. By default, it considers it to be a Postgres database, and give it the PG1 is your name inside Bucardo, what you're referring to it as, and then give it the name of the DB there. If you add an Oracle, kind of the same thing. DB type equals Oracle, a connection string, DB user, and any other information that you would need to connect to it. If you've got, by default it looks at the local host, but if you're connecting somewhere to somewhere remote, just say DB host equals whatever your host name or IP address is. And if you've got a different port, like for a development system or for security or whatever you're doing, just give it the DB port there. So at that point it knows what database sources and targets you have, but then you have to tell it what tables you want to replicate. So there's everything is a subcommand to Bucardo. So you run Bucardo add tables. If you only want to add tables that have primary keys, you do Bucardo add tables PK only. Hopefully all of them do, but you never know. If the database isn't given, it tries to figure out where those tables are. So for example, I haven't gotten into what a herd is yet. But if you only tell it that to import your inventory table, it'll try to figure out where that is. Or if you need to, you can just give it the parameter db equals and then your short name that you told it on this last slide. So you don't always, I mean, you don't just want to do tables, you also want to do the sequences because keeping those up to date is also important. So just do Bucardo, add all sequences. It'll grab everything that's in the database and add it to its list. So a couple different terms. A DB group is a named group of databases with probably with an assigned role. So if you've got a data center that maybe like a disaster recovery data center where you've got 3 different slave systems and you just want it to replicate to all of them, you can put those in a DB group and it shortens your configuration strings a little bit. So to group things in a DB group, just add DB group and then give it your give it a little short name like we did for the databases, and then give it the short names of the databases and their roles. So if we have, what's that, 2 sources, 2 masters, and 2 slaves, which kind of corresponds to our databases here. Just give it that first command. By default, it assumes the first database on that list is a master. Everything that appears after that is the target, so you can override that here, and that'll shorten up your command a little bit. A herd is a named group of tables and sequences. So if you've got like an inventory, if you want to keep all your inventory, your products, any coupons like that together, you can group that into a herd and refer to that as a group to any of your configuration statements. And a sync is a named replication event. So adding a sync. So you've got the tables in there, you've got the databases in there. You got to tell it, now you tell it what to do. We want to synchronize, give it a name like alpha, the herd, which we defined over here as inventory, products, and coupons. And we want to use PG1 as a source, PG2 as a source, PG3 and Aura1 are your targets. So that's pretty much all it is. And we tell it to validate, and that's when it actually goes and does all its own processes. And it calls a PL Perl U. It actually does everything through PL Perl U. And it goes, finds a schema, it adds its own functions, it adds its own triggers, looks up the tables, looks up indexes, and all that stuff. So that's all you really need to do to get it configured. At that point, start it up and tail the log and just see what it does. Pass it the status command. It'll do a little summary of all its syncs and everything it's doing. If you want a little bit more information on a sync process, just say status alpha or whatever you've named your sync. And the kick command, and I'll talk about that in a minute, basically tells it, I'm ready to go do your stuff. So here's what, like the example that, if you followed along in Postgres, and these slides will be up online somewhere, this is what your status should look like. It'll report last good, which hopefully is pretty recent. It'll have a running count of any rows that you've deleted, inserted. Any updates appear as a delete and then insert. So that simplifies things a little bit. If you've had a problem, like if the database connection was dropped, it'll tell you the last time something bad happened. At the very bottom there, it'll give you the error of that. And there's a number of other things which I'll just skip for the sake of time. So here's a recap. To get up and running, we install, we tell it the databases, we tell it the tables, we tell it where those tables go, and then we tell it to start. It's very simple. So they will be. I don't know if they are now. Keep an eye. There was a link to the wiki, the Postgres wiki that was sent out to the attendees list. And eventually, I think pretty soon after the conference, they'll appear in the talk descriptions on the Postgres Open site. So, like I said, a sync is a replication event. And to get it to actually, it's not like a continual thing. It waits for something to happen, and then it goes off and checks, pulls the rows, and it sends them off to the targets. So to do that, it can be kicked off in 3 different ways. There's a statement level trigger on any table that's involved in a sync. And that actually sends off a notify to the Bucardo process and tells it, OK, I've got new data. Something has happened. Come and grab it and do whatever you want to do with it. So you can, and with it being listen notify based, it happens pretty much instantaneously as soon as you commit. If that for some reason doesn't work for you, you can set a timeout on the sync properties. We have a client that's replicating from Texas, one of the data centers in Texas, all the way down to, I think it's Argentina. And they went to 9.0, and they're using Bucardo to replicate it. And we started testing, everything looked OK. Turned it on, and in their production process, I don't know why they didn't test it in the test process, they used prepared transactions. And as of 9.0, prepared transactions and notify don't work too well together. So they started, their production system started rejecting transactions, and they came to us and like, what's going on? It's like, oh, you didn't tell us that. So we set a timeout, and they're actually running a timeout of 1 second. So every second, the Bucardo process is checking that queue table, looking for anything new that's happened, sending it across. They're pretty high velocity, so most of the time there is something to replicate. So it's not too bad of a performance hit, but if you can't use notify for some reason, like prepared transactions, there's other options. You can also manually kick it off, which is this command here, Bucardo kick alpha. If you needed to do it from a command line or maybe even part of your script, that at the end of a maintenance script, okay, I know I'm ready to do the replication. So yeah. So let's see how it works. Each table involved in a sync has 2 triggers. All the source, this only happens on the source side. The targets aren't really touched, as far as apart from just getting updated rows. One of the triggers is a per row, and it adds the primary key of that row that is changed into a delta table. The other trigger, as I just mentioned, just sends off a notify that says, OK, I've got something to do here. When it gets that kick, when it gets that notification, the Bucardo process goes and gathers up any delta that's in that table, and then builds a list of affected rows. If there's more than one source, it tries to figure out which one of those is authoritative, and hopefully just one of them is, and that's whichever one that changed on. For any primary keys that have changed, run a delete on those primary keys on the database, and then do a copy. So it takes advantage of the fact that a update is, for the most part, essentially just a delete and an insert. So it simplifies a little bit. So yeah, I just mentioned there's no need to care about if the original was an insert, update, or delete. Truncate is handled too a little differently. It just uses a truncate trigger, and I think has some optimizations around that. If it gets a kick, it pulls all the sources to see if there's anything changed. If it finds a conflict, like the same primary key was changed on 2 different sides, it picks a winner, and then pushes and then it builds the winning row, how that looks, and then pushes it out to all the other databases. When it does that update on the target databases, all triggers, rules, foreign keys are disabled, because you don't want anything that has side effects to happen. Generally, because generally you'll be replicating those side effects that happened on the master too. So, to set up multi-master in a real-life situation, ideally, replication happens as quickly as possible. If all the other targets have the latest version of rows, then there's less chances of conflict happening. Set up your sequences to be staggered so that they generate uniquely, so that your like the auto increment value, set that so that it, for example, like a value of 10 or something like that. Each time you request a new number from a sequence, it's 10 above the last one, and then stagger a little bit so that your PG1 master will give like numbers like 11, 21. PG2 will do 12, 22, so that they never conflict. Most of the time, the default conflict handler is usually pretty good. By default, it's a latest row wins, and that can take care of most of the cases. There's an option, custom name. If you want to change the name of a table on one side to the other, you can do that in the sync and specify it in various places. For example, you're collecting a sales report from one side, and you want to, if you're sending off to a reporting database, just put it in like a table called Q4 sales and change that periodically, and you have a rudimentary partitioning system. Sources cannot be renamed, of course. Column names can also be changed. How are we doing on time? Not too bad. This is mostly useful for key value targets like MongoDB. And it will associate those different columns with the primary key value. So, like I said, it doesn't handle DDL. You can still run DDL. You just have to figure out a way of doing it on all different sides. If you're doing indexes, rules, triggers, not really a big deal. On the target side, triggers are disabled anyway, so you can just go ahead and add those anytime. It's fairly flexible. It'll tolerate new columns, change column types, dropped columns pretty readily. Because the delta tables are based on primary keys, changing that is a little bit more difficult. You essentially have to tell Bucardo to stop looking at those tables, change the primary key, and reinitialize it, because all its delta tables will at that point become invalid. One of the interesting new targets in Bucardo 5 is flat files. Yeah, I know I'm running out of time. Well, my phone just buzzed at me. Either that or I got an email. I have till 4? Oh, excellent. Oh, very good then. Flat files, and interesting, like I said, inserts, it runs as a copy. Updates, it runs as a delete, then a copy. And any deletes, it just does a delete. So instead of sending those commands directly to a Postgres target, it can route that to a file. So you get a unique, a time-stamped SQL dump file, in essence. That's just a series of deletes of whatever primary key changed, and a copy command with whatever new data comes in. So it's really good for creating an audit trail of the stuff that's happened in the database. And it also allows you to ship it through very slow methods. And in theory, it should still be should be faithful to your data. So some of the other statement-based replication, it should be a little bit more safer to use. I mentioned custom code a little bit earlier. One of Bucardo's strengths is the fact that you can write Perl routines that augment what Bucardo does. So if something goes wrong, if you've got a special case where you are writing to your target and occasionally something new comes from the source and it conflicts with the primary key or something like that, you can write a little bit of Perl to fix that up and just tell Bucardo to try again, and it'll pick up where it left off. Same thing with conflict resolution. If the same primary key is changed on 2 or more multi-master servers, they'll collide and conflict, and you also figure out which one is the actual winner of that conflict. By default, the latest one wins, and that's across all transactions and all databases. But you can override that, write a little Perl code, and it'll figure out, tell it which one is the winning database. That's not exactly true that there can only be one winning database. You can actually tell it that there's no winning database. We had a client that's going somewhere in the US over to somewhere in Australia. So really high latency They have conflicts all the time. And what they had was an integer field where all the bits are in essence different flags. So they have an automated process on one side. It could flag something, and use a response on the other side. It activates another flag or deactivates another flag. And they come and collide, and which one is the winner? Well, neither of them is the winner. We have to figure out, okay, this flag changed on this side, this flag changed on that side. So we have a row that's resulting that's not identical to either one. So we wrote a little routine that, luckily they keep history, so we can figure out what the intent of each of those changes was. And we tell Bucardo, don't do anything, I'm going to take care of it. And then we issue the update on both sides. And it works really well. That's an exception, though. Most of the time, your latest update wins is going to work fine. So that was an example of the custom code. You can run custom code before a sync, before the copy, before it updates your targets, after sync, after copy, after sync. It's kind of like the before and after statement and row triggers, kind of along the same lines. After sync, if you've got a cache, is great for cache invalidation. Before sync, can even tell a sync not to run. It's kind of like an advanced trigger. Currently, the only sources we support is Postgres. That's fine, right? That's all we really need. Well, there's sometimes, if we're migrating off of something like Oracle, that could be really handy to keep your new fresh and shiny Postgres 9.1 instance up to date with Oracle as it changes. And eventually the day will come where you can just shut the old one off and you're on Postgres from now on. So that's in the works. I don't think it's actually there now. Yeah, it's not there now. But getting it there in Oracle should be pretty straightforward. MySQL, it's definitely doable because it's trigger-based. It'll be a little bit more difficult. I don't think there's anything like listen notify in MySQL, so we'll have to work around that some way. And anything else is a huge unknown. I could buy that. So the comment was you can use advisory locks in MySQL to emulate something similar to listen notify. So, but as far as anything else, it really depends on what that source system supports. Currently, we have a lot of targets. I mentioned the flat file target, which is really useful. Log shipping is kind of a misnomer there. Supports MongoDB for all you NoSQL types. It supports SQLite. You can replicate to MySQL. You can go to Oracle. And you can go to the, as I learned over lunch, the no client Drizzle. In the future, we've got plans for Redis or Memcached, which is great, like a cache. Why wait for your cache to go check the database and get data that's been recently there? Just push it to the cache immediately. DB2, Firebird, others, by popular request. The target side is much more flexible than the source side, so there's a lot of plans there. So that's pretty much Bucardo. You can find it at bucardo.org. If you're interested in the community, there's several mailing lists. A lot of us just kind of sit on IRC and on Freenode. And if you find any bugs, let us know through Bugzilla. Sure. Yeah. There is the primary location is at bucardo.org. There is a GitHub clone, but it's Git. So it's the same thing all over the place. So just send us a pull request somewhere. Yeah. Mm-hmm. Right. It's in the logs. So Gesundheit. If you use something like tail and mail, it'll flag it and you'll get an alert with it. Apart from just logging it and moving on, I don't think so. It'll say that there was a conflict. The winner was. It'll tell you what the winner was. Which database, and it'll update all the targets, including any other sources. Yeah. I have no idea. That's a really good question. The question was, is there any parallelization on the apply phase? So like if you've got multiple targets.
So that like if your release last will being serialized for applying replication is that they talk about it as replication wise.
Mm-hmm.
And you're doing something not all that different. So it's only going to the process of applying changes.
As I recall, each sync gets its own, they call them kids, and each sync gets its own kid. And I don't believe that is I think that is a separate thread, but I don't think it splits that into other threads. Actually, I think it's a separate process. But I think it just updates each target in separately. In a serial fashion. So if it doesn't, I mean, if there's definitely room for improvement there. Updating all of them in parallel, that'd be great. It may already do that. Again, I haven't checked out the code for that portion of it, but yeah, that'd help.
So I was talking here about other endpoint.
Yep.
Is it developed by folks outside of endpoint much, or is it pretty much an endpoint product that has some other users?
Yeah, it's pretty much an endpoint product that has some other users. There are people that have submitted patches, and I think there's a few people that outside of endpoint that have commit on it, but for the most part, it is an endpoint thing. I don't know. It's there. It's very simple to do. That's it. Where's our summary slide? There we go. That's all you got to do. No, because the PL Perl U, that's actually in the Bucardo has its own database where it keeps its queue and anything that it needs its own state, and it connects from there through PL Perl U out to all kinds of other things. So I'm trying to think if there is any PL Perl U on the actual databases. So if you needed to isolate that, it's certainly possible that that's the only place that it's required. So you could have your own Postgres instance that has PL Perl U and just runs the Bucardo state database. Uh-huh. I mentioned just a little earlier, the only place I've found that the listen notify wasn't effective was a place that we were using prepared transactions. And in 9.0, listen notify and prepared transactions don't behave too well together. So we had to go to the timeout of, we're using 1 second timeout. And it's been hitting that every second for the last 6 months, I think. And I haven't checked in on it, but they haven't called me to say that something is wrong. So.
What happens if you have two servers and this one's replicating to that one?
Uh-huh.
And then the network connection is broken for a long period of time, and there's lots and lots of changes that need to be related. But
If
the connection comes back. Will it say,
Unlike Sloaney, which I believe takes a copy of the entire row and stores it in like a Q table or however, whatever type of table it does, Bucardo just keeps track of the primary keys that have changed. So if you have a lot of updates of the same primary key, as soon as Bucardo, if Bucardo can't connect for a long time, it'll see that, and there's some optimization for it, compresses it, and just grabs the latest version of that primary key, does the delete on the others, and says copy, this is the latest version of the row. Because you don't really care what's happened before that. You just want the latest, this is the latest, greatest version of all the rows. So it's got a lot of optimizations in that arena. Yes. The question was, does it handle composite primary keys? And yes, it does. There used to be a limit of 4, but I don't know if that's been removed. I think it was 4. Cool. Well, I think that puts us pretty much on track for our 45-minute talk. So if there's no other questions, then have at it.